In the previous video, I explained how to factorize a cubic expression, okay, by focusing on the constant term, okay. So on the similar lines, we can say the possible factors for this cubic expressions can be these three, as 1 and 20 are the factors of 20, and we want three factors for this being cubic. So these are the factorizations. Are these are three possible factorization, or there are many more? Obviously there are many more, because 20 has these factors: 1, 20, 2, 10, 4, 5. So with 1 and 20 we got these three possible factorization. With 2 and 10 we can get again these such three, and then with 4 and 5 we can get again these three. So in total 9 up till now. Then there is one more, 2, 2, 5. Okay, 2, 2, 5 also gives us 20. So this will again give us, with different combination of plus and minus, we'll again get 3 more, so 12. Okay, so you can say that there are 12 possible factorization for this expression. Okay, so the procedure is gonna be very lengthy, and in case if this number is bigger than 20, or you can say if this number has many factors, then this full will have many possible factorization. So by checking, assuming, guessing, okay, so that's guessing the factorization out of those many combination is gonna be a trickier task. Okay, so how should we proceed in such a situation? I suppose you are well acquainted with the problem now. The problem is, when the number is bigger, there are many possible factorization, and then checking them is gonna be laborious, as we did in the first video. No, so how to deal with this situation? Let's see. So that the work is not very lengthy, I'm combining the result of these 12 possible factorization of this polynomial. Okay, and what are the results? The results is that the possible constant term of the linear factors of this polynomial are +1 or -1, both. No, so its linear factors can have constant term as +1 and -1. They can also have plus minus 20 as the constant term, means either plus or minus, or they can have plus minus 2, plus minus 10, plus minus 4, plus minus 5. Okay, so these all are the possible constant terms. Okay, just like you can see here, +1, +1, plus 20, minus 20, okay, -1. And in similar way, these will give us either plus minus 2, plus minus 10, plus minus 4, plus minus 5. No, so these are the possible constant terms of the factors. Okay, so if +1 is a constant term, then this will become 0 when if we substitute x equals -1, and it will also turn all of this equals to 0. Okay, and if this is a possible factor, then this will also become 0 with x equals to -1. So these value also suggests that if these are the possible constant terms of the factors, then the possible zeros of this expressions are also these. No, if it is +1, then the possible 0 is -1. If it is +1, then the possible 0 is -1, and if it is -1, then possible 0 is +1. And if it is plus 20, then it becomes 0 with minus 20. Okay, so if this whole will become 0, that means this will become 0 with minus 20. So we can say the possible zeros of this expression, which is written in pink, are minus +1, because when it is plus 1, then it is -1. And when it is -1 constant, and then the possible 0 is +1. And on the similar pattern, we can write it as minus and plus 20, okay, and so on. Now these are the possible zeros. So this becomes 0 either with these or with these here. Okay, now there are in total 1, 2, 3, 4, 5, 6, 6 twos are 12 terms which can make it 0. Okay, now here comes, we have to start checking which one makes it 0. And do we have to check with all of them? Actually not, because we just want to get 1 0 of this. When we'll get the one factor, we can easily find out the others that I'll tell you later. Let's proceed with the checking of any of the factor. We'll start with minus and plus 1 because they are easy to substitute. You can easily rule out the possibility of any of them with the 0. Suppose plus 1 cannot be the 0 of this, because if we substitute x equals to 1, then all the terms are gonna be positive. Then how will they cancel and how will the result will be 0? So you can easily rule out the possibility of plus 1 as the 0. So I can substitute minus 1 and I can check for it. So let's check. So here I checked. I named this polynomial as polynomial in variable x, and instead of x I am substituting minus 1. So px changed to p minus 1, and here I substituted and I got to know that the polynomial turns out to be 0 when we replace x by minus 1. That means minus 1 is the confirmed 0. So minus 1 is confirmed 0, and what does that conclude? That concludes that x plus 1 is the confirmed factor of PS. Confirmed factor of PX. Why did I name it as PX? Because I don't want to write this full expression time and again. So I gave it a short name, a polynomial in variable x. Okay, so this is the confirmed 0. Now, there are two more factors as it is a cubic. So should we keep on checking? Okay, should we try out minus plus 2, minus plus 4, and what if they are not? Then it's gonna be a lengthy procedure, no? You'll check minus 2, plus 2 and somewhat like that. Okay, so the thing is, whenever there is a bigger constant number, there are gonna be many possibilities, and going through all of them to find out the factorization is gonna be lengthy procedure, and it's not good even, because maths is all about making the work easy. So what should we do? What is the perfect method? Okay, so the perfect method is, we have got one of the factor, we need not to find out the other, because if it is a factor, then we can divide this by this to get the remaining factors. Okay, and let's see, I'm dividing it. So here I have divided this by the confirmed factor. Okay, and you can see the remainder is 0, no? So it's the confirmed factor. Now what do we know? We know that this is the one factor and this contains the other two factors, no? Because this into this is actually equals to this, no? So here I've written this is equals to this into this. Okay, now this contains the other two factors and it's a quadratic expression. We actually know how to find out the linear factors hidden inside it by splitting midterm, no? So here I have proceeded for splitting midterm. It's 12x and this is 20. The two numbers whose product is 20 and their sum is 12 are 10 and 2. Okay, so 10 and 2, and if I further follow the procedure of factorization, so I'll get the two factors as x plus 10 and x plus 2. So the final factorization for this expression here is gonna be x plus 1 into x plus 10 into x plus 2. So we completed our factorization of a cubic polynomial, which is this. Okay, so we need not to find out all the factors by hit and trial, as we chose one of the 0 and then we confirmed it as one of the factor, no? So we just need one factor in case of a cubic one, because then we'll divide and we'll get a quadratic one, and we know how to find out factors hidden inside it. In case the polynomial in the beginning is biquadratic, means of the power 4, okay, then it is made up of 4 linear factors. Okay, 4 linear factors will follow the same procedure, we'll get one factor. But when we divide a biquadratic, means a degree 4 wala polynomial with this, we'll get a cubic expression here, no? Then we need to find out one more factor by guessing. Okay, so in case of a biquadratic, we need to guess two of the factors, but that should be followed as following finding out one factor, dividing, getting a cubic one, then guessing its factors again, confirming one of the factor, then again dividing, somewhat like that. So just mend your ways. How will you deal with a polynomial with degree 5? But the degree 3 polynomials are to be dealt with this procedure. That's all for this video. Thank you.